Right, we did 17 two ways in class. I'm going to go ahead and do them both again. The first is sort of the way that we chatted about previously in class, which is factoring out. So recognizing that both of these terms in the student's derivative have an x minus 1 factor, and then we know that we can factor out the sort of smallest exponent version of that. So we can take an x minus 1 to the negative 1/2. That should be able to come out of both terms because you have a term here and a term here. All right, the second term is straightforward. That's going to be a 1/2 x plus 2 because that's what's the leftover stuff, right? When we look at this actual um, function or this particular term of our derivative here, we can see that's the leftover bits, right? We remove that x minus 1, we factor out the x minus 1 to the negative 1/2, and this is what's left over. Now, for the first term, it's not as obvious, but we've discussed this. We're going to end up with an x minus 1 to the 1. Now, this is going to always be what happens based on that product rule when we end up with a power because we did an n and an n minus 1 with that power rule. But you can verify by just multiplying these out and adding those exponents. 1 plus a negative 1/2 does indeed get us back to that positive 1/2 that we had originally. Now, if we clean this up, we have an x minus 1. The 1 power is not doing anything. We can distribute that 1/2 plus 1/2 x plus 1. And we can see here, okay, this minus 1 and plus 1, those become a 0. We can add 1x and a half x to get 3/2 x times this. And then we realize, oh, okay, we're trying to head towards this. I can see the 3 and the x, that's here, right? 3 and the x. Okay. I've got that 2. There she is. And then, oh, x minus 1 to the negative 1/2, that's the same thing as the square root of x minus 1. So check. Those are all the same. Cute. The other way to do this was to simply move into our radicals right at the beginning. So rewriting this as x minus 1 with a square root plus x plus 2 over 2 square root of x minus 1, right? The negative puts it in the denominator with that 2, and then making these two things have common denominators. So we can actually get down to a single term because the thing we're trying to show that this is the same as is this, and we only have one fraction, and here we have 2. So we can multiply it, both top and bottom of this by 2 times that square root of x minus 1. And what's going to happen here, we'll be able to finally add these. The square and the square root on this, we're going to undo each other. If you take the square root of x minus 1, I mean, essentially what happened was this. Times the square root of x minus 1, which is what I've written here. So we have a 2x minus 2 plus x plus 2 all over that denominator. And we end up with our 3x over 2 square root of x minus 1 that we saw in that final thing. So different way to get there. Depends if you want to do that factor trick that we learned or if you'd rather just work with some radical and rational expressions to simplify.